Hello, my name is Topuz. I am currently a student at Akon University, master degree in architecture. The professor of this course is Dr. Semih Aryıldız, and today we are going to talk with you about ecological high-rise buildings. At the beginning, I'm going to try to explain you a little bit about the background of high-rise buildings, why they started to make high-rise buildings and what was the reason behind of it. We cannot really find a direct cause so that we can say this was the reason why mankind started to make high-rise buildings. But if we look closer at the buildings made back in the time, we can see that they had at the beginning religious and military functions. And from later periods, they were formed with functions such as trade, housing, and accommodation. They were made to symbolize power, and high structures symbolizing faith were built in history. We always have admired and respected tall buildings from the past until today. It's safe to say that the now known to be tallest in the world were the Egyptian pyramids, with a Great Pyramid of Giza and an original height of 146.5 meters. It was an early example of a high-rise building, and it remained the tallest structure in the world for about 3,800 years, until the construction of Lincoln Cathedral in 1311. Here you can see also another example, a photograph of the Lincoln Cathedral. So when we talk about high-rise buildings, what even is a high-rise building? What do we understand when we talk about high-rise buildings? There are a series of reasons in mankind history of why society preferred to construct a high-rise building. We cannot take a specific item to make a description about the context. We have to take a few factors into account, as in the cultural structure of the country the building was built in, the economic reasons behind it, the reasons, purposes, or other reasons. While defining high-rise buildings and taking these elements to note, we can ask ourselves various questions about this topic. For example, at which height is a building acknowledged as high-rise buildings? Or with what kind of purpose was this building built? One of the most definite answers to this question was made by the Tall Buildings and Urban Life Council. They have made three main categories in height, proportion, and tall building technologies. If we take a closer look into these three categories, the first category would be height relative to context. The easiest way to explain this would be a building is considered high-rise buildings if the buildings around this one specific building are shorter, much shorter in context to the one building. Because there could be a 50-floor height building in a metropolitan city, and we wouldn't really consider it a high-rise building because all of the other buildings are high-rise buildings too. But if you put the 50-floor high-rise building into a suburban area, then we can call it a high-rise building again. The second point would be the proportion. Not only does the height of the building play an important role in defining the status of the building, but also in proportional side, also its width. A building may not be particularly high, but very slender to give the appearance of a tall building, whereas a building with a large footprint and wide size areas may not be classified as a tall building at all. Then the third category would be the technologies relevant to tall buildings. If a building has specific traits such as vertical transport technologies, structural wind bracing as a product of height, it can also be considered a tall building. As we will continue with this video, you will see that the big differences between all of these buildings made in different years differ from each other from the technologies that were used. With our growth in technological inventions, the buildings also started to grow higher up towards the sky. In comparison with history's first high buildings, we can see that reasoning to lack of knowledge and possibilities There was it to making the building taller, serious problems such as water pressure and the absence of an elevator were the main reason which prevented us from building higher. In conclusion, technological development plays always a big role in our possibilities when building and constructing. Let's take a short look in the historical development of the tall buildings. The historical development of tall buildings. When we look at the tall buildings in history, we see a rapid change at the beginning of the 20th century when we started to develop glass technologies, high quality concrete and steel as new possibilities of material that could be used in high-rise buildings. With those technologies, problems like post-stress, corrosion, resistance reinforcement, composite systems and materials, elevator system, water pump, heating, cooling, and ventilation systems could now easily be solved with this new approach. And the last thing would be, and this is the most important one, the computer programs we use in construction make also a really big difference and a big development, because now we can solve complex calculations, wind and earthquake resistancy, or we can design different forms more transparent and higher. Now we continue with the examples of high-rise buildings in Turkey. The first ever high-rise built in Turkey's history is the Kahramanlar Business Center, formerly also known as Kızılhan Emekhanı. The architect of this building is known as Enver Tokay. The building was made in 1965 in Ankara. It's 76 meters high and 24-story skyscraper. It was also the first building with a glass curtain wall facade, primarily inspired by the Lever House that was built in 1952, blended with some of the facade characteristics of the United Nations Secretary Building in 1952 in New York City. Our second example is going to be the Mersin Trade Center. The architect of this building is Cengiz Bektaş. Building was made in 1987 in Mersin. This is the second and also a very important example we can show. Mertim, it's called for short. It was the tallest building in Turkey from 1987 when it was completed in the year 2000. Then the İş Towers were completed. Now let's continue with more modern examples in Turkey. At the moment, we have the Metropole Tower Istanbul, which is considered the tallest high-rise building in Istanbul so far, made by RMGM London, built in 2016, located in Istanbul. Not only is it the highest building in Turkey, but also considered one of the tallest buildings in Europe. Istanbul is a city who is in a constant danger of an earthquake, so the tower has been engineered to withstand an earthquake with a reinforced aerodynamic structure. It has a height of 301 meters and a total of 58 floors above the ground. Our second example is the Skyland Istanbul. Architect is Eroğlu Holding, was built in 2019 and is also located in Istanbul. It's located in Sarıyer's Ayazo neighborhood. It has a height of 285 meters and 65 floors. It is one of the tallest buildings in Istanbul and Turkey and the 8th tallest building in Europe. Skyland Istanbul is home to a 5-star international hotel with 830 residences, 504 office spaces and 300 rooms and a conference hall for 550 people. The next building is Istanbul Sapphire. Architects are Tabanlıoğlu Architects, built in 2011, also located in Istanbul. It is the 17th tallest building in Europe, excluding Russian territory, after the short London Bridge with an antenna height of 261 meters with a total of 54 floors. The next chapter is philosophy of eco-high building. What is sustainability? In the 21st century, we started to face major problems in cities and cities who were constantly growing. When talking about sustainability, we have to be aware of the sources of the world we live in. Our supplies on this earth are not inexhaustible. The carbon footprint of the humankind continues to be a major problem, generally all over the world. So our goal is to minimize our carbon footprint. With that, we start to use energy sources that can be renewable, working with material that can be reused or recycled. We can analyze sustainable architecture with three main headings: environmental, social, and economic. When we combine all of those three headings, we come up with sustainability itself. Therefore, the next question would be, can skyscrapers even be sustainable? When we are making skyscrapers in our big cities, we have a few good things. For example, a high-rise building does not use that much space like other buildings. We can house a lot more people in high-rise buildings. That can help growing in popularity. It can help or growing in horizontal axis. We can start building in a vertical axis. It's an important factor in creating comfortable spaces for people. We have to take into consideration the heating and cooling of the buildings. The framework is guiding us how we are going to construct it. The goal is to reduce energy consuming and save energy in bioclimatic designs. The two sources that are the most important things when we build a skyscraper is the sun and the wind. We can directly or indirectly use these both sources inside of our building. Also important things would be, of course, the location of the land, the building envelope, ventilation, and heat needs without compromising the quality of life and comfort. Let's take a look at bioclimatic design approaches in traditional longhouses. Structural designs are high roof, presence of loft, and high stilts. Ventilation openings are fixed transom or the kanban. Materials we could use are split bamboo, timber, sago palm leaves, thatch. Daylighting we can make with light tunnel, transparent roof coverings. There are some more examples on how we can make a skyscraper more sustainable. One of those things would be, and this is probably one of the easiest things that we can make, is locally sourced construction materials. If we are going to use locally sourced construction materials, we are not going to transport materials from a further field. And this helps us in saving energy. A really good example of this is the Bank of America Tower, located near Times Square. The architect of this building is Cockfox Adamson Associates, was built in 2009 in New York. The building was made with nearly 40% of locally sourced materials. Another point is wind-resistant design. For this, we have the example of the Shanghai Tower, made by Marshall Strabala and Yun Xia TGAD, built in 2015, located in Shanghai. This tower is 632 meters high and stands up against intensive winter conditions at its highest point. The curved spine of its design was ingeniously incorporated in order to redirect wind force, allowing for a less resource-intensive construction. Another thing to make a high-rise building ecological would be green buildings. This example is in Singapore, made by Wuha in 2016. The name of this construction is the Oasia Hotel Downtown. It's literally a green building, the design itself, with vertical gardens and green vegetation on the whole structure of the building. The aim here was to reduce the building's carbon footprint and creating a beautiful, relaxing, and natural environment for residents. We can also use wind turbines when we build high-rise buildings. This example is located in Bahrain, was built in 2008 by Atkins. It's the Bahrain World Trade Center. It's a perfect example on how to use the building efficiency while saving on energy. It's a 2,040-meter high building in a Middle Eastern island and was inspired by traditional wind towers. The next thing would be temperature regulating facades. This is the Ping An International Finance Center, made by Kohn Pedersen Fox Associates, built in 2010 in Guangdong, China. The building uses a glass facade to regulate the air conditioning inside of the building. It has a double facade that is regulating the air inside of it. This is a small SWOT analysis for high-rise buildings, where we are taking into consideration the strengths, weakness, opportunities, and threats. This is just a general example. The strengths of a high-rise building would be, like mentioned before, a small footprint, small foot area, dealing with high density issues and lack of available land, space saving, and accommodation, more residents than shorter buildings. Weaknesses would be the repair and maintenance, provision of efficient plumbing services, wind and earthquake resistant designs. The opportunities are potential to decongest urban sprawl, better option for a green building, more lit, airy, and provide more surface area to install solar panels. The threats are negative impact on the visual composition, where it's located in the city, and if it's a good design inside of the city building, negative visual impact on skylines, and fire safety solutions. Now we have a few eco-high building design models as examples for this work. The first example is a solar curve in New York City. It was built in 2019 by the architect Studio Gang. Its height is 61 meters. Solar curve highlights how, by taking into account their users and surroundings, contemporary commercial buildings can be good neighbors and improve crowded urban circumstances. It's characterized by its proximity to the repurposed High Line, which runs diagonally over the property's easternmost part. A variance was needed to flip the light and air setback from the street side to the High Line side, allowing the building bulk to be relocated to the west. When compared to an as-of-right plan, daylight modeling revealed that solar curve's form and location will roughly treble the park's yearly hours of direct sunlight. When we look at the design of the building, it was made so that with the position of the sun, the park in the middle of the buildings will always be lightened. Therefore, it's called solar carving. On several of the office floors, these carvings also provide for private terraces with views down to the park. Solar Carve's floor-to-ceiling glass takes use of the building's western exposure and openness, collecting sunshine to minimize energy usage, allowing panoramic vistas in all directions, and forging a strong visual link with neighboring structures. This is a floor plan on the located area of this building, and this is a section of it. Here you can see the solar carved building shape permits more sunshine to reach the High Line than the permissible envelope according to analysis. The next example is the UN Tower. It was made by B+H architects. The design proposal of this building is adaptable to an ever-changing cityscape. It's a building that was not built yet. It's a building design proposal that we can take and we can rebuild it in any place, in any shape with any materials that we want to, wherever we want to. It's a really sustainable project, and we can use it as accommodation or a commercial building. It's up to us how we want to build this. We can change it like we want to. These are some examples of the buildings from the top. The circular form of the tower was inspired by an architectural concepts that have been proven for millennia. The sight of curvilinear forms stimulates a favorable emotional reaction in the human brain, according to several recent research. The next example is the spiral. It was made by Bjarke Ingels Group. It's located in New York, USA, and the completion date is going to be 2024. This is a picture on how the glass facade was made. In New York City, we have the important High Line. The High Line is a green, let's say, band that continues in the middle of the city and ends at the place where the building was located. So with the geometrical form of that building, the High Line is going to continue up to the top of the building. And on each floor inside of the building, you can have access on the indoor gardens. This is an example of it and a closer look on how these floors work with each other and the indoor gardens are connected to each other. The next example is One York in Toronto. The architects are ERS Architects. It was completed in 2016 and is located in Canada. This building is using Envape Deep Lake water cooling treatment. The building is basically connected to a lake nearby and is using a pump system to bring the water inside of the building, use it as a cooling system and a heating system. Rainwater is also collected from enormous cisterns as well as neighboring towers and utilized in drip irrigation as well. And the building and the water that is collected are going to be used in toilets and urinals inside of the building. LEDs for outside illumination in addition to several occupancy and daylight sensors. The building has a photovoltaic solar panel network, which generates a large quantity of electricity, is also installed on the roof. These are the tasks that were completed inside of the building and around it. Our next example is the 15 Hudson Yards. It was made by dealers Cofidio plus Renfro. Is located in New York City, was made in 2018. The difference of this building to the other buildings is that they used the cold warping process while molding the glass to save more energy while building it. This is also a really good example of ecologic high-rise buildings. Here you can also see a section of the building and the main plan where it's located. The next building example is Stantec Tower, made by Stantec, located in Edmonton, Canada, completed in 2018. It is one of Western Canada's tallest structure and part of the country's largest mixed-use developments. It also has a LEED Gold certification. Our next example is going to be the Hearst Tower. The architects of this tower are Foster and Partners. The building is located in New York City and was completed in 2006. It has a complete height of 182 meters. Hearst Tower is the first green high-rise office skyscraper in New York City, and it reflects Foster and Partners' creativity in creating a groundbreaking architecture. The structure was constructed by using 85% of recycled steel, and heating and air conditioning systems use both outdoor airflow for cooling and ventilation for 9 months of the year. That means we have 25% less energy than the identical office building that meets the state and city's minimum requirements. The building envelope incorporates high-performance low-emission glass with inbuilt roller blinds that made deployed to decrease glare and reduce solar gain. Because the building is naturally shaped by the surrounded structures, enormous skylights at the podium level were employed to provide light into the atrium space. Here we can see a structure of the building and a picture of its outside and a good site plan. The basement is made of reinforced concrete. Here we can see a few sketches that were made by Foster themselves. Here we have a matrix, but we are going to take a closer look at it. In conclusion, with the changing and developing technologies, it's possible to make our world more livable and more sustainable with many different methods. With the spreading and increasing population, we started to take up a lot of space in the world. To use less space in future, the use of skyscrapers will become more useful and almost mandatory. In this case, the problem we need to address is how much of the materials we use when building a skyscraper can be taken from nature, how efficiently we can use the space we get from nature, how much we can integrate energy sources that will not run out in nature into the building. We can benefit from solar and wind energy by minimizing the energy use inside the building. Here you can see our matrix table in detail. I have taken a few buildings, so you can take a look at it if you want to. The last part of this course is going to be my own project, my own proposal of a high-rise building. We have made a detailed review and criticism of the tall buildings, and we will begin to shape our sustainable high-rise building proposal under the best conditions. The complex program, the main idea in the design process is to make adaptable design with an use-neutral complex plan. After design and planning, program, terrain, and usage modifications can be accommodated. The site is going to be in Kartal. We are going to work in Kartal. Our project area will be located in Cevizli district on this area. Next to our high-rise building area, there is the Istanbul Anatolian Palace of Justice building located. So therefore, our building could be a commercial building supporting the Palace of Justice. Here are the traffic and transportation conditions in Kartal. You can see the roads and the bus stops in this picture. Also, the closest airport to Kartal is Istanbul Sabiha Gökçen. It's 11.49 kilometers away. The Istanbul airport is 31.9 kilometers, and Cengiz Topel airport is 58.15 kilometers away. There are two metro stations, Soğanlık and Hastane Adliye Station. The chosen area is right on the edge of the main road D100. Here you can see an analysis of rainfall in this area. The driest month is July. There is 28 millimeters of precipitation in July. In December, the precipitation reaches its peak with an average of 108 millimeters. Let's take a look at the climate. It's typical Mediterranean climate, four-season continental environment. The coldest months are January and February, while July and August are the hottest. Here you can see month by month the weather averages in Kartal and also we have here a sun path analysis on our area. The flora and fauna, brownish forest soil without lime, makes up a big place of the research area, whereas alluvial soil makes up just a little and brownish soil without lime makes up 503 hectares. All the terrain types and communities cover the 7,238 hectare area. In addition, the seacoast contains largely sand and clay soils, while the Yakajik Hill includes limestone and quartz deposits. Draft project report, philosophy, ideas, and proposals. Like we said before, the goal is to design a flexible and sustainable high-rise building. It should be able to be constructed in any place needed, regardless of where it's at. The skyscrapers will be a really big, important place in our future because it's a big advantage for us, especially in crowded and dense metropole cities. We can house a lot more persons in a high-rise building. Housing, accommodation, commercial areas, and shopping areas can be easily fit inside of the same structure. Our ideas are, we are going to use some principles in our building to support our proposals. We are trying to use only locally sourced construction materials for this design. Because when we transport materials from further sources, we create a high CO2 emission. We want the opposite of that. If you use locally sourced materials, we can save money, time, and we could be more eco-friendly. The material types are also important. We can reduce the high consume a lot with recycled materials. We can use recycled steel material, for example. Our building is mainly be made of steel and glass facades. Also reinforced concrete for floors. When we are trying to create concrete, studies have shown and proposed an alternative and more eco-friendly material type, which consists more of ash than cement, which is called ashcrete. This is also something we could integrate in our building. When we use glass facades, we are facing new problems like indoor heating and cooling. To help us solve those problems, we have a few types of glass facades to use. 1, solar control glass. 2, low E glass, also known as low emission glass. 3, tempered glass. We are going to use, or we want to use, vertical gardens, indoor gardens in our building. To make our building more eco-friendly, we can also use vertical gardens or indoor gardens. It's not only eco-friendly, but it also helps the human psychology. Here we have a list of the requirements in our building. Now we are going to see some plans, sections, and renders of the design proposal. This is the place where our building is located. This is a simple site plan that I made to show you a little bit more of my project. The most important part in this building is the core plan. Here you see a section and the section detail of the building. The height of our building is 240 meters tall and contains 60 floors. The design approach. Next to the building and the project area there is, as stated above, the Istanbul Anatolian Palace of Justice. Considering the site plan and building form, layout and square design of the Palace of Justice, a harmonious and uninterrupted design was created that would suit and complement both this building and the round square. The original building is in the figure as shown. These are my sketches that I tried to make while deciding on the construction's form. Here you see some building renders with sun direction and shadows. The top of them is in the morning in summer, and the down is sun directions in the evening for summer. Now at the very end, I'd like to show you some render pictures of the building and close the video. Thank you for listening.